Right, in these series of questions I'm going to go through, they're all basic trigonometric problems. Now, up until this level of mathematics, you probably only had to find one value where this is true. But as we've seen from the previous video in this playlist, that the cos curve goes on forever, and therefore you get lots of values where 0.5 will equal cos x. Now, 0.5 is one of those values you should know. There are certain values you should know. You should know the cos of 0, 30, 60, 90, and so on, and any multiples of those. And the radians equivalent of 0, pi by 6, pi by 4, so I missed out 45, and pi by 3, and pi by 2, and so on. Okay, so if you don't know those exact ones, they're ones you should know. They come up quite a lot, and it makes your life a lot easier if you know them. So if you don't know them, though, we do have calculators, and you can press inverse. Let's just get menu 1. So press inverse cos of 0.5 and get ourselves an answer. And this one's in radians. And you've got to be careful on your calculator. So I'm just going to go and just change that into degrees mode, and that's how you go about doing that on your graphical calculator. Shift setup, and you just change that. So go back to menu 1. So exit from there, and let's just do that again. Let's go back and press execute, and we now get 60. Right, just like our graph said. So we see that we get 0.5. Our first value we get is 60. Now we asked for all the values between 0 and 360. So let's keep going along and see what's the next value we get. Well, the next value you get is 300. Now, when you're doing this, you won't have a nice graph drawn like this. You'll probably just be drawing a little sketch in your head of cos. You know that that is 60, and therefore you realize that this point is 360, and that this part of this curve and this part of this curve, let's just highlight that, these two parts of the curves are symmetrical. Okay, so that distance is also 60, hence you can then realize that this value down here will give you 300, and that's how you get your other answer. Let's look at something a little bit more interesting. So let's look at this one. We're doing cos x plus 45 equals minus 0.5. So we're down here. So let's get our calculator. Now minus 0.5, you'll get to a stage where you should be able to work that one out in your head. But until you do, let's just go back and put a minus in here and press that, and the calculator gives us 120. So for x plus 45, we get our first answer as 120. Okay, a calculator is going to give us all the answers between, for cos, 0 and 180. It will give us an answer. You notice there's one particular answer for every single value in this region. Okay, in that range of angles, okay, or should I say domain, and this is the range when you come on to do functions, you only get one answer for each angle and one answer for each value where cos equals something. Now we have to go on and find the other values. So again, you draw the line across at minus 0.5. You realize this is 120, this is 180, and that this is going to be, that's 60 there, this will be 60, because you have symmetry here and here. These are exactly the same shape of the curve. So the next value you're going to get is 60 plus 180, which is 240. So you'd be expected to memorize the shape of the curve. Okay, you get your first value out at 120. You realize you got 180 there. So looking for your next value, you realize that distance and that distance must be exactly the same. They're both 60. So this comes out as 240. And just check there's no more values between 0 and 360 was true. So those are our two answers. I've only found where x plus 45 equals 120 and 240. So we found where x plus 45 equals 120 and 240. So therefore we need to take those away, and we get 45 away from that will be 75, and 45 away from that will be 195. And that gives us our answers. Now, a very common mistake is to get this 75 here, and then instead of using these values on our curve, the student will think, okay, 75 is here. Where else am I going to get the same value? There's 90, that's 15, add on 15 and get this value. That's going to be 180, 270. Add on 15, we get 285 for the second value instead of 195. The reason that is just they just left it too late. You really need to, if you're going to do that, this graph has to be the cos x plus 45 graph. You can only use the cos graph at the point where we just did the inverse cos. So when you've done the inverse cos, got your first angle out, you find your second angle at that point, and it's really critical you find at that point and not later on in the question. So those are our two answers. Right, in this question, we're going to solve sine 2x equals 0.5. And there's two ways to look at this question. I'm going to take you through one way and then talk about another way afterwards. So sine 2x will equal inverse sine of 0.5. Now you should know that that's going to happen at 30 degrees, but if you don't, we can just do shift sine of 0.5 on a calculator and get our first angle out at 30 degrees. So we've got our first angle out at 30 degrees, we draw a cross and we find the next value. Now you won't, as I said, we won't have this nice symmetry, nicely drawn curve. You will have to use symmetry on your little sketch that you would draw on your graph. So you realize that's 30, you realize there's 180, take 30 away from 180 and you will get 150. And that gets you one answer, another answer. So that's two answers we've got. Now, in fact, there are four answers to this question. Okay, I'm going to show you how they come about. If I continue the sine curve on past 360, I get another two answers, which at the moment are outside our range. So whenever you get these two x ones, you need to be very careful. Okay, so I'm going to just find this other one. So 30 times 360 is 390. So that's going to be 510 there. It's just 360 more than this value. So we're going to get 390, 360 more than that. Once you've got your first two values, all your values repeat every 360. So 360 more than that is going to be 510. So 2x will equal these values. So we want to find out what x equals. Divide by 2, we get 15. Divide by 2 equals 75. Divide by 2 gives me 195. Divide that by 2 gives me 255. And you see now all our values are between 0 and 360. Now, how do you decide how many angles to get? You know, is there another one after that if we divide by 2? Well, what you can do is you can just find a couple of extra ones and keep working them out. So you can find another one at this stage and divide by 2 and then realize actually no, it's going to be bigger than 360. Another way is to just realize if x is between 0 and 360 and we've got sine of 2x, then we are going to be looking at a range 2x, 0 times 2 is 0 still, but 360 times 2 is 720. So we go all the way up to 720. And if we actually just continue this graph, we see that's the point where we get to 720 and there are no more answers after that. So you can realize that our range will change according to what's inside the sine of x, and that we could use that to decide our new range and just work out values in that, or you could work out more values you need and cross out the ones you don't need. Okay, this is obviously going to be more elegant and quicker, but if you're struggling in the exam, just work out plenty of values and then cross out the ones you don't need. Again, do be careful. If you just get the 30 at this stage and get the 15 and then use your graph, so at 15 you'll be looking up the wrong values. Okay, 15 here, 15 off 180, you'll be looking up the wrong values. It's really, really important at the point where you do the inverse sign, that you find all the values that you're going to need, and then do the rest of your calculations after that. Right, last one, we're going to combine all of that together and actually make it a bit trickier by using radians. Students don't tend to like radians. So the first thing I'm going to do is divide throughout by 4 equals 2 divided by 4 equals a half. So cos of half, now this is in degrees, I'm just going to change this to radians. Our value we would get is pi by 3. We know this is pi by 2. We should know this is pi. You should know this is 3 pi by 2. And you should know that 360 happens at 2 pi. So we're going to do inverse cos of a half. So theta minus pi by 4 equals cos minus 1 of a half. And we get our first answer as pi by 3. Our next answer, okay, we're going to take pi over 3 away from 2 pi. So take that away from 2 pi. That's going to give you, well, 2 pi is 6 lots of pi by 3. Take 1 pi by 3 away, will give you 5 lots of pi by 3. It does help to be good at fractions when doing these questions. And then that is equal to 0, theta minus pi by 4. So theta will equal 3 pi by 3 plus pi by 4. And let's get that into a common denominator. So let's put that as 12ths. So that's going to be 4 12ths plus 3 pi over 12. That will give you 7 pi over 12 for this one plus. And if we do 5 pi by 3, that's just going to put into 12, so that will be times by 4 gives you 20 pi by 12 plus pi by 3 pi by 12. So we get 23 pi by 12 here. And that gives us our two answers.